Hello, my name's Jared. If you're new here, I'm a Rubyist. I run a software agency called Supergood Software where we build Ruby on Rails based e-commerce systems using a platform called Solidus. Today, like most days, I am going to be working on the Advent of Code Christmas puzzles, just like I did last year. We are at day 22 is the next one. So we only have a few puzzles remaining. 22, 23, 24, and 25, which is usually an easy one, followed by a sort of a gimme on the last one. We're doing them in Ruby because that's what I know. I've used a lot of programming languages, but Ruby's what I work in. So let's not forget to switch over to the code this time, like I did in my last stream, and take a look at day 22. Operating at these extreme ocean depths has overloaded the submarine's reactor. It needs to be rebooted. The reactor core is made up of a large three-dimensional grid made up entirely of cubes, one cube per integer three-dimensional coordinate. Each cube can be either on or off. At the start of the reboot process, they are all off. Could it be an old model of reactor you've seen before? And this is a reference to puzzle from last year. Let's see, which one was it? Oh, Conway cubes. That was a fun one. To reboot the reactor, you just need to set all of the cubes to either on or off by following a list of reboot steps. Your puzzle input, each step specifies a cuboid, the set of all cubes that have coordinates which fall within ranges x, y, z, and whether to turn all of the cubes in that cuboid on or off. For example, there's instructions. They give us cuboids. Second step turns on. So okay, so we're turning them on and off. The initialization procedure only uses cubes that have x, y, z positions of at least -50 and at most 50. For now, ignore cubes outside that region. Last two steps are fully outside the initialization procedure area. All other steps are fully within it. After executing these steps in the initialization procedure, that's how many cubes are on. Okay. So this is a test example that we can use. And we're going to expect this 590,784. So 100 times 100, that's going to be a million. Like surely part 2 is going to have to do with expanding outside of the 100 range in each direction. So 50 plus minus 50. I mean, I guess we just do the naive thing here. So let's take our input, and map it split it on new lines, and map it to some kind of, what are we calling these things? Operations or steps? Steps. So we can make a step class. Okay, so we're going to initialize these. We're just going to tell them to parse the given line. And then we can apply parse method here. Let me just look at it. We'll just play around and get that working. Oops. Meant to only run this spec. All right, so we have string. So we have two pieces here. We have whether it's on and coordinates can be gleaned by splitting the string on the space. And then what do we do with coordinates? Just eval them. Oh, that's horrible. I've received some criticism from my friends for using eval on a bunch of these inputs that are technically valid Ruby, and they're right. Okay, so we'll use those two lines. All right, so I'm just going to attempt to solve A22 part 1. So if now my input's been fetched, so it hasn't been tampered with yet. You can't hack me with this eval. But if you did happen to somehow tamper with that input in that time, nice work. And then we'll create this. This is just going to create so now we have a set of inputs, hypothetically, hypothetic stacks, I guess. Calling them back. For given what am I missing? Why would new be expecting? Oh, these are keyword arguments. No, I forgot that. Okay, so now we have six steps. Can iterate over and do something with. So we're trying to do again. We're trying to find the number of things that are lit on. So let's do steps. So we'll create a excuse me. These are what are the reactor grid cubes on cube. Cubes then will be our set. So this is gonna be a set of coordinates of cubes that are on. Okay. So we're going to do steps dot x each do so we're going to iterate over branch not working there. Iterate over each set of values, and then we're going to do whatever operation makes sense. So first, these are just a step. Second, we're going to next if x is greater than 50 or x is less than -50. And we can do that in each step this time. Do it for y, and here, we'll do it for z. So inside there, we know we need to potentially do something. So now I'll say if step on, let's do something else. So if the step is on, then we want to add cubes, and we want to insert x, y, z into it. And it's not, then we want to delete x, y, z. Cool, that works. It's not fast, which is probably where we're gonna run into trouble. And we can optimize this further. We could constrain the ranges. We might need to. I assume the input's actually really big, but that gets us an answer. Continue to part 2. Part 1. Now that the initialization procedure is complete, you can reboot the reactor. Starting with all cubes off, run all the reboot steps for all cubes in the reactor. Consider the following reboot steps. After running the above reboot steps, this is how many cubes are on. Just for fun, that's how many are in the initialization procedure region. Starting with, again, with all cubes off, execute all reboot steps. Okay, so this is going to be a optimization type deal. We need to find a way to do this more efficiently than we're currently doing it. And let's just switch to this other input for both. Because it's a real spooky input, you know? Whoops. Sorry. So let's double check that this works for our oops, that's not what I meant to do. I have to run my spec. So how fast does this take? A long time. So we know we can at least constrain this for part one, because we can clamp. I'm sure. Let's see. Ruby range. What can we do? How can we make new ranges? Cover. It's like we just have to. So we can do x. What is this? X dot begin -50. I'm probably just gonna want to like make a move. Constrain X. Constrain Y. I feel like none of this whole approach is off, but I do want to do this case anyway. Constrain takes a range, and it returns a new range that is from R to begin -50 max to R end 50 min. Think. Yeah, okay. All right, so that's all set immediate performance problem. Probably makes our part one a lot faster. It does. That's cool. Date 1 station. What do we do to do this for big numbers? This is like, we're well beyond being able to store this. This is in whatever comes after trillions. Let's just take a look. I don't think we looked at the input. It's not a huge number of things, but it's enough. What did I change here? Oh. Right. That. Let's focus part 2 now. So I'm just making sure that I can reuse this class because I think they're just like having this like data container here still seems useful, even if my approach is gonna be different, but we'll see. Yeah. Page 22, part 2. No, this approach is not going to work. Oh, I guess I need to take 1. Need to make sure I initialize these with string through and now we're not going to constrain the manager here, and we'd have a test that just runs forever. Cool. I'm curious as to what kind of progress it makes. Still thinking about how we might approach this. Yeah, so then it does the smaller ones fast, and then it gets to the big ones, and suddenly things grind to a halt. Go take a look at step 17. These ones. Okay. What do we do here? Think about storing counts, or like what kind of data structure we could use here to handle this. Tricky. Not immediately seeing it. like even storing one record for like every single one that is on and nothing else, still too slow. Hmm. See, I'm thinking about solutions where I could do something like just store the ranges and try and like map them or something, but I like collapse them all instead of iterating over them. Oh, sorry. I just don't see a solution there. Oh, we got our part one answer for part two. Interesting. Good with that. Oh, false there. Oh no. Yeah, this is too slow anyway. There's just like too many possibilities. So like I could loop over the whole space and just like go backwards through the list until I see one that hits it. But the size of that, that's still like the smallest numbers here are like almost negative 100,000, and the biggest numbers here are like almost 100, or are like over 100,000. So we're like in the ballpark of whatever that is. Yeah. I mean, apparently more, because we're expecting a value out of this that's bigger than this is. Isn't that 5 commas? Yeah. Let's go look at that previous puzzle. Well, this one was just 4D, which was annoying, but doable. Okay. So if I was just turning some on and then turning some off, we could like calculate the intersections. That's not what we're doing. I have overlap on all of the different things. In order to do them in. Like when I see a big number, like a big result number like that, that makes me think, hey, I need to be keeping track of counts. I need to be finding a way to count these things, not finding a way to keep track of them. So I'm wondering if I'm supposed to be doing something with cuboids here. Like if I need to do math around like intersecting them. I'm just thinking about all the irregular shapes that could happen and how annoying that's going to be. Okay, what about dividing the space? So all of the numbers given in this effectively represent divisions. in the space. Woo-hoo. So you could sort of visualize it as the space being divided up into unique areas. And so now in this test example, we've only got like 50 unique areas per axis that we would need to look at, or not 50, like 100. But still, that's in the realm of what we can compute. And then we really only need to figure out whether one pixel in each one of them is on and the size of it. That's right, isn't it? It seems like it would work. So we like order all of our boundaries through our X, our Y, and our Z. We compute the size of each area. We look at only one pixel or one core or whatever it's called to see whether it's on in that area. Still looking at like a million things, probably, maybe even more. It's a neat idea, even if it. Well, let's check a pass at it to see if it works. So we want our steps map, not flat map actually. So we're returning the s dot x dot in x end sort each. Oh, but we want to know the n plus 1. Right? Because that's where the next region is going to start. I think that's right. I'm going to do the same for Y, for Z. I'm like not even sure this is actually going to be fast enough, but it's kind of a neat approach if it actually works. I don't know, maybe it's what everyone else is doing too. Who knows? And we just need to iterate backwards through the steps to figure out you can just reverse it here. We want to iterate backwards to the steps, find the first one that matches ours, and then we'll know whether it's on or off. So the size of this region, oh shit. The size of this region is going to be maybe we want to do each cons for each of these. because then it says start X and end X. And so the area is going to be I think it's gonna be the end minus the start minus 1 because we got those plus 1s in there, but I think we still need those. Width is our let me just call these. We'll just do this. End X minus start X minus 1 times across the lines is Y. And then we'll just say if on start X, start Y, Z, plus equals, oh, sorry, I said count here. We'll call it size. And then we just have to figure out what they're on. And if step equals steps, find find a step, we want to return step dot on, yeah, step dot on. Otherwise, we just return false. I don't know, that could work. Oh, I didn't finish what I was doing here, so. That is a surprisingly close number over the is I wrong about the plus 1s or something? Or the minus 1s? I think so. Oh, I guess I was. Let's see if that gives us the right answer then. It's not fast by any stretch of the imagination. Still doing hundreds of thousands of iterations, but it's faster. I wonder what other people are doing. Still really slow. this is not necessarily acceptably fast. Well, how long do you all want to sit here and watch that run? So we'll kick that off. In the meantime, I want to unique these. I don't think that'll change anything. Kind of want to know how many this is, though. $500 million. Oh, that's still too many. I thought that was a pretty clever approach, too. We must be able to filter them better. Because we could do something like we can do things like any on. How do I want to do this? So something like that. We can there. Just try and filter more of the values out. Then once we have we do like next unless back on start act. And then we can do next unless XY on start. That might reduce our number of iterations a bit. Gets us the wrong answer too. Because I'm just looking to figure out, like, are there any X's on here? If there aren't any X's on, we don't have anything to count. I guess we could iterate only over no, that's not. So I don't know why this doesn't work. Oh, now I know. Fix it. Okay. It's not going to be fast enough though. Guess we can make this thing and put some diagnostic information for us. We can just break some things. X steps is going to equal this thing. Then do Y steps. Z steps. Cool. Now we can know I mean, we could do the reject earlier, but each con, we can just do dot reject A, B, X1 question mark. Oh, we can't do that rejection there, though. We can only reject one, the other one in advance. We have to do the rejection in here. Worth it then. See, this is already doing 15 or 1.5 million. Just finished. So maybe this isn't the approach. I thought it seemed clever, but it seems too slow as well. Well, we don't need to complete the size every time. We're not going to use it. Expect that'll make a meaningful difference. It's just some math. How do we make this fast then? I mean, I don't see, like, I feel like this approach is sort of at its limit. And I mean, I could start. This should just be true. Flame grab time? I feel like we're just gonna learn that. We're just gonna learn that this approach is slow. How else could we do this thing? The solution probably actually works for part 1 too, doesn't it? Let me try it. Apparently, both sides should be passing. We got 1 pass. And passes. Take this. Go to 322 part 1. Paste that same solution in. Oops. Oh, that's not right. Oh, we don't have X on. We gotta move the whole thing over. Cool. All right. Well, at least there's that. So is it then iterating over it once? Slicing up the cuboid regions as we go if they intersect. And then just computing all their sizes. Is that it? And then we're just left with a bunch of cuboids at the end. I'm sad that my approach wasn't quite good enough. Faster, but it's not fast enough. Okay. Oops. Get out of here. It's far too slow to be acceptable. Okay, fine. We'll just... So we want to basically scrap this. No, we don't need these methods. I need those methods. So we'll have a cuboid equals nothing. I'm going to introduce a cuboid object. Maybe I keep doing that. This is pasting random crap in here. Cuboid equals start new. It has a start I'm gonna call these x start, x end, y start, y end, z start, z end, and we will have keyword in it. Keyword in it. True. So we're gonna keep the cuboids in a set. That way we can insert existing cuboids and not cause problems, I guess. So if I understand this problem correctly, we should be able to do a single pass over these instructions. On each step, we split existing cuboids on the axes of the area that the step specifies. So for that first step, we'd split along -5, 48, -31, 23, -19, and 34. And then we would does that work? No, that doesn't work. Because we also have to split the one we're inserting based on all the axes of the existing ones to ensure we've completely subdivided the space. And ensure that any possible unique areas are still unique. I guess that works. Then if it's an on instruction, we delete or we add all of the cuboids that result from generating the one we're inserting. If we're deleting, we delete them. Okay, and then it'd be better if we actually did some kind of collision detection or something. I feel like that's too much work, right? So steps. So this is going to look like steps. look, people who want to get banned. Love it. Rip. Now we can, and then at the end we'll have set up cuboids, and we'll just sum them by their areas. And that'll be the answer. So for each step, I just outlined it. First, we subdivide existing cuboids. Then we subdivide new cuboids. Then if on, insert new cuboids, else delete new cuboid. All right, we can sort of flesh this out. This part's easy. Let me say if step on, we guess we can't start at the end. So let's convert step. So we'll say new cuboids equals step 2 cube. So now we have new cuboids. We'll transform that at some point. And then if step on, we'll say new cuboids each cuboid n. We'll trust that because cuboids is a set. We won't end up with any duplicates. And similarly, delete any matching cuboids in the case where we're deleting. Okay, what could this code look like? So we'll need to do along X, Y, and Z axes. So it'll be like cuboids, flat map. Do cuboid, subdivide X, and then we'll use new cuboids map. X divisions, maybe. So let's go and turn an array. And we can just do it 3 times. We're using a bunch of methods we haven't written yet, but that's fine. And then we can do similar, we can do new cuboids. cuboids map, flat map. So this should also be a flat map. Hypothetically, there's only ever going to be one thing in there, but each one is going to return 2 values. God, this is hacky, or at least it's just, this doesn't seem fun. So this one, so our new cuboids, we're going to flat map them. No, we're going to subdivide X across the existing cuboids flat map X divisions. I think I do the same thing for Y and Z. Cool. I mean, now we're missing a whole bunch of methods on our cuboid class. Here, let's just format this a little nicer. A bunch of classes, or a bunch of methods. We are going to have to define area. We are going to have to define subdivide X, as well as, I'm gonna leave it. And then X divisions. So X divisions is easy. This one is X start and X end plus 1. Actually, we can do all our XYZ ones here over here. Cool. That's that. Now we need to subdivide. I mean, seems like a really convoluted approach. Please, chat, tell me if there's some simpler approach that I have completely missed here. This one we already know. These are X end minus X start times Y end minus Y start minus Z end minus Z start. So now we just need to implement our subdivide XYZ methods. So I mean, we immediately know that we're going to reject subdivisions. No, wait, we don't know we're going to reject subdivisions outside of our, or no, I think we do. Okay, so let's really start with that. So we know we don't care about X divisions that are less than start X or greater than That's less than or equal to start x. Oops, that's not. That works. Or greater than and x for x and not getting backwards. Start x. Now we're getting to XOR stuff. So those ones we care. Those are the only ones we care about. We know we want to go from. So we'll call these valid divisions for now. And so now we can do does this work? I think I'm missing something, but I'm close though. These plus ones, the index stuff is messing with me. So this, we should be able to map this to like cuboid new I feel like this isn't right. Because I feel like I've got some +1, -1 worries here. Because if I have a cube that's 0, 1, 2, and I want to split it along 1, yeah, okay. I think I need to pull in my ending there. So I still end in the same spot, and each of my divisions ends one before the next one starts. I don't know, that makes some sense to me. That's why, that's why. But now we move this down here. And then, okay, so yeah, swap those off for Zs. Oh, and I've got some issues here because I've set everything to ZX. Z start and Z end. Okay. So I've implemented all those methods, but I think I never did step to cuboid. It's fine though. Copy this junk. And this is just going to be X begin, X end, Y begin, and Z begin, Z end. And let's fix these. I don't know. Let's find out what mistake I made now. Wow. Well, it's fast. Oh, I see. Starters. I could chain this all. I don't really know why I'm not. Well, not fast. Even slower than before. Wow. Is it because I have bugs or because it doesn't work? 41, 48. 41. No. Excuse me? Day 17's back. Oh, I don't. Okay, well, this is not. This is not working. It's changed in my office. How slow are you? Very slow. Why are you so slow? Hmm. What do we do here? I thought this was a kind of clever approach, but apparently it doesn't work at all kind of approach. What's it doing? It's so slow. I mean, subdividing the cuboids isn't going to be fast, but it shouldn't be that slow. I could write tests. Well, I'm a little lost. How slow are we talking here? Very slow. Let's... I could use the other test input, but I'm not sure how much value it would be. I already had a solution at one point that worked performance-wise fine on small inputs. So it's never finishing subdividing the new ones once we get to step 3. Oh wow, I'm not sorting them. That's a problem. Oof. Doesn't help me, but I think like it's hard to know currently whether I have a logic bug or a... I guess you're right. I could use the smaller test input to determine whether I've got a bug in my logic or... Oops. Put that here. See if this even actually produces correct results for the small input we were given in part 1. Good thought, good thought. I mean, it's not a smaller though. But I mean, I'm probably being curious as to where we're falling over here. Which one of these steps is so slow? Oh, I can't do that. Need those return values. Start subdivide. Yeah. And it's just subdivide. What? How could there be so many? And that's them. Is the -1 in the input? Which -1 in the input? I mean, this still shouldn't be so prohibitively slow. It feels like I'm hitting like an infinite loop here. We're not duplicating any work there. I mean, that helped us. This is still not nearly fast enough, though. With one z equals in the input. I'll take a look once this is gonna finish. Step 15, too slow, too slow. That's minus 50 to -1. But yeah, they are inclusive. That's what you're asking. I don't actually know how many steps there are in this one. So I think this must be it getting to those last couple big numbers. Or it just gets slow. I just want to see if it works. I don't know how many lines are in that test input. 22. Okay, that's gonna take a bit. All right, well, I feel like this approach is not it. I might take a break, get some food and stuff, and come back maybe and try. Obviously not a good approach. I'm bummed that I can't see what the fast approach is for this. Well, I'm gonna take a break, go get some food. I'm getting real hungry. It's dinner time for me. So I'm gonna go do that. But I might be back later to try and finish this off. Thanks everyone for coming out, and see you next time.